Hello friends, in this video tutorial today I am to discuss PERT, that is Program Evaluation and Review Technique. But before I discuss about this, I must refer to my previous video tutorials uploaded, that is on construction of network, what is network analysis, how do we put the activities in a network, how do we jot down the duration, calculation of latest start, latest finished through backward computation, earlier start, earliest finish through forward computation, determination of critical path method, and crashing. Lot of concepts, lot of exercises I have put in my previous video tutorials. Here in this video tutorial I have taken an example, practical example knowingly, wherein I have already put the activities in the network so that it becomes easier to make you understand, and it takes lesser time because it involves even more calculations on this part. So this is why the activities have been networked. Here it is based on the calculation of most expected time. Here it involves three types of times. Time given in three forms. One, that will be denoted by A, known as most optimistic time. Optimistic time is that time actually in which the activity is completed, or you can say the shortest time in which, real time in which the activity is completed. M will denote most likelihood or moderate time, means that the moderate time normally more than the real time, because real time is just a very ideal situation. So where in moderate time, more than that real time, when one completes a particular activity, the time which one takes is known as most likelihood time, which normally everybody may take. And B is the most pessimistic time, means the ones who are not, who are lethargic or may take a longer period of time. So that is the most pessimistic time, which is the longer in duration. So normally these three types of times, that is A, optimistic time, M, most likelihood time, and B, pessimistic time. In such three information regarding time about a particular activity will be given. If such time frame is given, then it indicates that we will apply PERT. Say here, in short, the names of the activities written here: A, B, C, D, E, F, G, H, I. Their nodes from the network have been determined. So what normally we do is that we first of all write down A, that is most likely time, M, that is optimistic time, sorry, M, most likely time, and B, pessimistic time, the three times above the activity. Like here, for activity A, 1 to 2, so 4, 6, 8. For example, activity B, that is with node 2 to 3, so above this arrow 5, 7, 15. So here the different times are given. Now what we are to do here is that we need to calculate mean time or expected time. The formula for calculating mean time or expected time is given here, that is TEI, we represented by, that equals to A plus 4M plus B by 6. Now in this case, A plus 4M plus B by 6, if we calculate here, then Say for example for activity A. So A plus 4m. A means here 4 plus m. 4m, that is 6 4 ja 24. 24 plus 4 28 plus B. 28 plus 8, that is 36 divided by 6. So that comes out to be 6. In the same fashion, 7 4 ja 28 plus 5 33 plus 15, that is 33 plus 10 43 48 and divided by 6. So it comes out to be 6 8 ja, that is 8. So expected time here is 8. In the same fashion, for the other different activities, here it comes out to be 8 4 ja 40, 48 plus 4, that is 52 plus 2 54 64. So here 8 8 ja 64, and in this fashion we can calculate for all the nodes the different activities. Here it is 20, say it is 10. Now here again 9 4 is 36 plus 8, that is 44 plus 10 54 plus 6, that is 60. So 60 by 6, that is 10. And in the same fashion here it will come 8 2 and 7. That's how we could calculate the expected time for each activity. Now having calculated this, now we need to calculate standard deviation, in fact here, that is sigma I. The formula for sigma I is b minus a by 6. So b minus a by 6 means b is this one, say for activity 1 to 2. So 8 minus 4, that is 6. 8 minus 4, that is 4 by 6. So here we will write 4 by 6. Then 15 minus 5, that is 10 by 6. Here it is 12 minus 4, that is 8 by 6. 25 minus 15, that is 10 by 6. 26 minus 10, that is 16 by 6. Then 16 minus 8, that is 8 by 6. 12 minus 4, that is 8 by 6. 3 minus 1, that is 2. So 2 by 6, and here again 2 by 6. Now if we reduce it, so here I am not showing it, actually 4 by 6 is basically 2 by 3. So now if we square it, that is sigma I square 2 by 3, so it comes out to be 4 by 9. So here it is 4 by 9. 5 by 3, that is 25 by 9. This is 4 by 3, that is 16 by 9. In the same fashion, for this it is 25 by 9. Then we have 8, so 64 by 9. Here it is 4, so that is 16 by 9. Here it is 4, 16 by 9. And then here it is 1 by 9, 1 by 9. In this fashion, we could now calculate the standard deviation and variance, that is sigma square, for each of the activities. Having calculated this, now we need to calculate the critical path. Because we will do analysis only for the critical activities. So here if we look at it, and before we go for calculating the critical path, let us write down the expected times for each activity just below the arrow. Say for node 1 to 2. So expected time is here 6. Within bracket we can write. For 2 to 3. So here expected time is 8. So 2 to 3, that is 8. 2 to 4, that is 12. 3 to 6, that is 20. So that's how, that's like we can write here 3 to 5. Here it is 18. 3 to 5. So here 18. 4 to 6, it is 4 to 6. So 4 to 6, here it is 10. In the same fashion, 5 to 7. So here it is 8. 5 to 7, 8. And then we have 6 to 7, 2. And 7 to 8. So here it is 7. Now we can calculate the longest duration. If we look at this path, say 6, 1 to 2, 1 to 2, 2, 3, 2, 5, 2, 7, 2, 8. See how much does it come out to be. Another path, 1 to 2, 2, 3, 2, 6, 2, 7, 2, 8. Another path, 1 to 2, 2, 4, 2, 6, 2, 7, that is 6 to 7 to 8. So here 6 plus 8, 14, 14 plus 18, so that is 32, 32 plus 8, that is 40, plus 7, 47. Here 6 plus 8, 14, 14 plus 20, 34, 34 plus 2, 36 plus 7, 43. So 6 plus 12, 18 plus 10, 28 plus 2, 30 plus 7, 37. That means the critical path is this one, and here we will calculate the variance actually only for this one, and here the total expected time is 47 days, and the critical path is 1 to 2 to 3 to 5 to 7 to 8. Now if it is expected from us that find the probability that this particular project is to be if it is to be completed in 55 days, what will be the probability? So here we need to find out the standard deviation. But before we calculate the variance, we cannot talk of standard deviation. So for these activities, sigma I square, here it is say 1 to 2. So for 1 to 2 is 4 by 9, 2 to 3, that is 25 by 9, plus 3 to 5, so 3 to 5, that is 64 by 9, plus 5 to 7, that is 16 by 9, plus 7 to 8, that is 1 by 9, so it comes out to be 110 by 9. Now this 110 by 9 is actually sigma I. So sigma I is equal to, if you calculate it, you will find that this is 3.496. Now having calculated this, and so here we can normally apply the normal distribution, that is Z is equal to x minus mu upon sigma. So here for this activity, Z is equal to x minus mu upon sigma. So x is 55 minus 47 upon 3.496, and here it comes out to be 2.89. So here the table value at Z is equal to 2.89 is basically 0.4981 Z table value, and plus 0.5, so here it is 0.9981. That means 99.81% is the chance that the project can be completed within 55 days. That's how we can apply program evaluation and review technique. So I have tried my level best to make you understand. I hope this illustration is going to be highly helpful for you. Thank you very much. If you understand, if you have understood it, so please like it, share it, and subscribe it, because the moment you like it, it really motivates us. Thank you.